Hi guys, so today we will be doing a Leetcode question called maximum spending after buying items. Okay, so we're given values, right? These values is a list of lists, right? So inside this list is actually represent items in each shop, shop 1, shop 2 and shop 3. So in each day we're given access to the rightmost item in each shop, right? So if we buy an item in day 1, then it would cost us like here, right? If we buy product 2 from shop 1, like this guy, in day 1, then it could cost us the price of that item multiplied by the day count, which means 1, right? So the question here is that we have to return the maximum amount of money that can be spent on buying all the products. So we see here that the cost could be equal to the price multiplied by the day count, right? So the price then, so like we want to return the maximum amount of money, right, that can be spent. We want to return the maximum cost, which means if we are at a smaller day count, like day 1, then we should buy item that has a smaller price, right, and leave the item with a larger price for later days, right? So here, as you can see in the example, this item with the value of 9 will be bought on the 9th day, right? So let me try run to you through a quick example. So let's see through this example. On the first day, then we are given access to value 1, 2 and 3, like these rightmost item in each row, each shop, right? So okay, so we want to choose the item with the smallest price and buy on that day, which means it will cost us 1 plus 1 is equal to 1, right? Okay, after that we delete one element. Okay, we add one element in now. Which one to add in, right? Because like 2 and 3 is still accessible, right? This guy is still the rightmost item in the shop, and we just remove this guy, so this guy should be added into the queue, right? And in the second day, then we will choose the smallest item that is accessible again, right, which means this guy, and we bought it at price day, which means it will cost us 4, right? And we delete it again, right? We delete this guy again. We delete this guy, which means we have to add this guy in, right? And we repeat this step and we can achieve the maximum cost. So the way that I will be doing this is actually by implementing a heap queue, a min heap, right? So we will initialize a variable called candidates. This this guy will store all the value that is accessible on each day, right? And at most then it can only contain the number of shop, right? Which means the number of row, which means in this case 3, right? And then we will have a variable called result and day count, and we will do a for loop while day by candidate, which means if we still have accessible to any candidate or this guy is not null, then the loops continues or day -1, because in the first day then this guy is null, right? If day equal to 1 on the first day, then we will need to loop through the values and then append this guy into the candidate list, right? For I in range length values, values, and then we hit Q. Here's the tricky part, because we need to heapify this candidate, right, in order to like get access to, when we popping it, then we pop the minimum value out of it, right? Hit push candidate, and one more thing, when we push a value into the candidate, then we need to also push the index of the row, right? Because like when we push this guy in, for example, 2 1 3, when we first we have candidates like this, right? 1 2 3, and then we delete, we use these guys, right? We bought this guy, so now it's like this. So when we pop one element out of the candidate, then we need to like find the exact row that is in, and then add the new left right mode element to the heap, right? Which means in this case 4. And so we need to, when we push a value into the heap, then we need to push the value and also the index of the row. So candidate values I, left mode element is -1, right? And also the index is I. Okay, that is for day 1. And after that, we need to do like best index equal to heap q dot heap pop candidate, right? So we pop the item with that is accessible but with the smallest item, smallest value out, and then we compute rest day, right? Okay, after that then we check if the shop still have any item, then we add the right mode item into the candidate into the queue, right? If not, then we just continue with the loop. If values index, right, then hit Q, hit push values index -1 and the index. Yep, okay. After that, then we increment the day count by 1. oh, I'm sorry, we need to like pop this guy out of the rows, right? So I pop. Yep. Okay, so we should return reset. Oh, yep. Okay, so let's click submit. Okay. So the time complexity of this is n log n log, where m is equal to number of shot, right? So why? This while loop is run to will be run equal to the element of the row, right? And then whenever we do a hip push or a hip hop, then it would take us O log m, where m is the size of the candidate, and in this case then m would at most be equal to the number of shops, right? So here's the time complexity, and also the space complexity could be out of m, right? So m is the number of shops. I hope it makes sense. See you guys later. Thank you for watching.